Good morning, students. I am Mr. Malagouda Patil, Assistant Professor, Department of Mechanical Engineering. Okay, in this semester, I am going to handling this open elective subject, that is non-conventional energy sources. The students who took this subject as open elective, irrespective of your branch, either it may be CS, ENC, electrical or mechanical students. This subject is an open elective subject. This subject you can choose anybody to learn the course. Okay, I will congratulate you people those who took this subject as your open elective subject in this semester. Because this subject is very important, because being an engineer or the responsible human being, you should know the which are the sources of energies, that is non-conventional energy sources which are available in nature, then how you going to make use of those energy resources for our benefits. Okay, because nowadays we are totally depending on the conventional energy sources, because these conventional energy sources like petrol, diesel or the coal, these are in coming days, these energy sources are going to deplete, they're going to end. So instead of that, you should divert towards the non-conventional energy sources like solar energy, wind energy, so you can easily improve our lifestyle, and even you can meet our energy demand which is available nowadays. Okay, in this video lecture, I'm going to just brief you people about this course content. Then in the next video we'll start with the module 1. Okay, as I previously told that the subject name is a non-conventional energy sources. The course code is 18ME 651, and it is also, if you come with the marks, that is internal having 40 marks and externally you're going to get a 60, so 100 marks question for that will convert it into 60. So that is as usual as you studied in the normal subjects. Okay, then if you come with the if you are learning any subjects or any course, so that each course is having its own learning objectives and the course outcomes. Okay, so these are some few listed 4 to 5 learning objectives of these non-conventional energy sources. Okay, you just go through that, because in this first learning objective, you to introduce the concept of solar energy, is radiation, collection, storage and application. Okay, so how you going to study the concepts of solar energy and the radiation of solar, and how you going to collect that solar radiation and solar energy, and how you going to store that. So this is about, we're going to study about, these are the learning objectives. And if you come to the course content of the module 1, so this is the introduction. Module 1 is the introduction. So in this introduction module, so people can going to learn about what is the source or energy sources. And as of now in India, because our country is one of the developing countries, fast developing countries, what is the energy demand which is available nowadays, so that you're going to study in this first introduction part, that is Indian energy production and reserves of commercial energy sources and need of non-conventional energy sources. So how you can overcome these conventional energy sources by make use of these non-conventional energy sources, and energy alternatives. Energy alternatives means what? So basically you are going to classify these energy sources into conventional or non-conventional energy sources. So as I told previously, so nowadays we are mostly depending on the conventional energy sources like fossil fuels, okay, petrol, diesel, so that kind of energy sources you are nowadays utilizing. But these energy sources will going to deplete at one day. So because of that, so you can find some alternate energy sources to overcome these fossil fuels. So for that, the alternate energy sources are like solar energy, thermal energy, okay, photovoltaic, because photovoltaic means what? So it will convert the solar energy into electrical energy. There is water power, there is hydraulic turbine, so wind, biomass, ocean temperature difference, so tidal waves, geothermal, so many things, mainly nuclear energy. Okay, these are the some very important non-conventional alternate energy sources which are available in the nature. So we can make use of these energy sources and meet our energy demand, required energy demand. And if people are going to study about its each energy, alternate energy sources advantages, disadvantages, and it sometimes they may ask the difference between the different energy sources. So that things you going to briefly going to study in the introduction part. So next is that is about the solar radiation, because solar is a very important nowadays, because all developing and developed countries are concentrating on the solar energy, because is the main abundant amount of energy is available in the nature. So then you can make use of that maximum utilization of solar energy for our useful application. So for that purpose, so you're going to study in detail about the solar radiations, because you know that solar radiation is what the rays which are coming from the sun. So it is having its own thermal energy, heat energy, so many things, and the intensity of that radiation. So all that things you're going to study about the solar radiation in detail. You're going to study it in the solar radiation content. So next, after that, measurement of solar radiation, that is very important, because as we know that the solar radiation will get vary from morning to evening. So okay, the intensity of the solar radiation is maximum at the afternoon time and is very less in the morning time. Again it will get reduced towards the sun moving towards the evening time. Okay, then how you going to measure the solar radiation? So using some instruments, that is pyranometer, a shading ring, pyranometer, sunshine recorder, schematic diagram, and principle of working. So that you're going to study some about some equipments you're going to study. So which are used to measure the solar radiation. So this is about the module 1. From the module 1, you people can going to get the 2 questions of 20 marks each. So you people can able to attend any one question. Okay, this is about the overall introduction about this non-conventional energy resources that you want to study in the module 1. So module 2 is about again further continuation of the solar energy. Okay, that is solar energy geometry. So plugs on plane surface, latitude, decreasing angle, azimuthal angle. So many things. The one we have some numericals, simple numericals on the solar radiation geometry. So that things will going to it is of some numerical type. Okay, so that you will get the idea how the solar radiation or the solar energy is going to vary from morning to evening, and at what time you get the maximum solar radiation. So that things you come to know in this module 2. And next, the radiation plugs on the tilted surfaces. So that we're going to study in this second module. Again, next further is a solar thermal conversion. Okay, so once you know that how the solar energy is important, then how you can convert that into some our useful work, okay, useful energy source. So that is what the collection and storage of the solar energy and thermal collection devices, liquid flat plate collector, solar air heater, concentrating collector, that is cylindrical, parabolic. Okay, so these things related to the solar energy, so you want to study it here, that is space heating, space cooling, because nowadays major difficulties with the non-conventional energy sources is that you cannot store it a huge quantity of energies, because whatever the energy is available that directly can make use for some other application. If you want to, it is very less possibilities are there to store that, because even if you want to store those energies, so it requires huge investment for the storing devices. Okay, so these are some applications. So how that solar energy, because solar energy it is a heat energy, so that heat energy it can convert into a other form of energy like thermal energy, so electrical energy, or any other kind of energy, so using some different devices. So that you can study it in detail about this in this solar thermal conversion. Okay, again next move to the module 3. Okay, so in the module 3 that is a performance analysis of the liquid flat plate collector. Okay, so as we know that nowadays in all the cities or the developing and developed countries, they are using the solar water heater, solar photovoltaic panels to convert the solar radiation into electrical energy, or that solar energy into thermal energy. So those things you detail you going to study different liquid flat plate collector you going to study in this. And next that only I told that the photovoltaic conversion. It is a device which converts the directly solar radiation to electrical energy. And next the module 4. So you going to deal about the that is wind energy and tidal power. Okay. So again wind, you know that that is wind. So it is also a huge quantity and it is available in the nature. So you can extract that power energy, wind energy into the some other form of energies again. Basically we all you know that. So if in nature any kind of energy which is available in the nature, that is directly converted into electrical energy first. And so you can because see that even solar energy is available, you are converting that solar energy into electrical energy first. Even wind energy is there, tidal power is there, geothermal energy is there, biomass is there, hydrogen energy is there, even hydraulic turbines are there. In any non-conventional energy source you can take, so that available source of energy is directly converted into electrical energy only first. So you're not converting that into any other form like thermal energy or heat energy, not like that. So you are converting all those non-conventional energy sources into electrical energy. So why? Because later on this electrical energy can convert into any form of energies again. Okay, it is a reverse way. Again, you can easily transmit this electrical energy from one location to other location. So that's why. So any source of energy which are available in the nature, so that you can first convert it into electrical energy only. Okay. So similar way. So again, this wind energy. I think all of you are aware about the wind turbines. Nowadays they are installing. Okay. So to convert that wind power into wind energy into the electrical energy. Okay, that we are going to study different types of wind energy turbines. Okay, so in this again along with that tidal power. Okay, tides will going to generate in the seas. Okay, tides and the waves, what you can call. So it is also containing some the energy. Okay, so how you can convert that energy into some useful energy with the help of some devices. So that will going to study it in this tidal power. Okay, so that is in the fourth module. You people can going to study about this wind energy and tidal energy. Okay, tidal power. And next you come to the last module, that is the fifth module. So fifth module, so in this you're going to study the different types of energies, that is the geothermal energy, energy from the biomass and hydrogen energy. Okay, so how to generate, how to convert geothermal into electrical energy, how that working principle of that convert that geothermal into electrical energy. We want to study biomass. As you all know that biomass is very important. So due to this, whatever the kitchen waste or the that is a fermentation, that will convert degradation of this waste material into can generate the biogas or the biomass. Okay, and last one is the hydrogen energy. Okay, so about the how you going to generate the hydrogen and how you going to store that, because nowadays hydrogen is very powerful energy source, but one difficulty what we are facing nowadays is the storage of hydrogen is very difficult. Okay, so that's why this is you can overcome those difficulties. So that we're going to study in detail about this hydrogen generation. Okay, thermal decomposition of water, thermochemical production, biochemical production. Okay, this is about in the fifth module. Okay, it is very informative course. Okay, you'll get the many knowledges about the different energy sources in the nature. So then it will come to the course of outcomes. Once you learn all the 5 modules of this course, then the students can able to understand at the end of this course is first for understand the need of energy demand and the various non-conventional energy sources we can come to know. And next is analyze the various components used to generation or the harnessing of the solar energy, and analyze the performance of the solar flat plate collector system, analyze the harnessing of wind energy, tidal power and ocean energies, analyze the harnessing of thermal and biomass and hydrogen energies. These are the 5 course outcomes. Okay, at the end of this course the students can able to understand, they can able to come to know these things, okay, by this course. Next, if you come to the question paper pattern of this subject is as usual, as I told that it is containing the 5 models. On each module you will get the 2 questions of each question of 20 marks. So you can attend 1 question from each module of your choice. Okay. And again each question is having sub questions. Okay. So like that, this is, you can go to this point, you come to know that what is the question paper pattern, that is final examination question paper pattern. And then you come to the textbooks. So here for related to this non-conventional energy sources, so by BTU itself is prescribing in the syllabus that conventional energy sources by BH Khanna, and solar energy by Subhash P. Sukatne, and non-conventional energy sources by GD Rai. So by my end, I am going to suggest to people that you can refer the GD Rai for this subject, non-conventional energy sources, and particularly for solar energy, so you can go with this Sukatne. Okay, these two are enough for this course, and along with that some reference books are mentioned here. Okay, so you just go to this reference books. Okay, then next is, okay, so this is about this introduction, brief introduction of this course, that is non-conventional energy sources. In next coming lecture videos we'll start with the actual syllabus.